Today we're going to be talking about the good, the bad, and the ugly of MAC addresses. My name is Sean Wilkerson, and this is Hacker Eyes. If this is the first time you've made it to this channel, you just found us, welcome. If you haven't had a chance to yet, hit the subscribe button. Don't forget to hit the notification bell down there. We have a very good video coming up. Let's just say this. I have a video coming up that's I think it's extremely interesting and provocative. And in some instances, it may be considered scary, and it should be coming up in a couple of days. It should be released. Okay, this video is part of our lexicon series where we try to simplify typically complex technical terms. And this video is going to be on MAC, the Media Access Control, MAC addresses. That's what we hear about. Ooh, that MAC address. So what is a MAC address? How are we going to explain it? How are we going to define it? We're going to provide a simple real world couple of illustrations, and then we're going to talk about the good, the bad, and the ugly later on in the video. I've got these linked below. A couple of things from Technopedia. A MAC address is responsible for the transmission of data packets to and from the network interface card. Oh, okay. Don't know if I like that definition because MAC in itself really doesn't have a responsibility. It's a physical address. So Technopedia explains a MAC address. The basic function of MAC is to provide an addressing mechanism and channel access so that each node available on the network can communicate with other nodes available on the same or other networks. That's a little better, but still, there's got to be an easier way of saying that. So let's do a couple of oversimplified real-world comparisons. Let's start with the street address. For us to use that as an example, we have to assume a few things. The first assumption is you know what your current address is, like where you are right now. A second assumption is you know where you want to go or what you want to accomplish. What do you want to do? The third assumption is the two destinations should be indirectly or directly attached or associated or connected. So basically what I just said is you have to know what your source is. You have to know a destination or service that you want to use. And there has to be some kind of physical connection, a physical layer. There's a physical connection between these things. Okay, that's not much better. Can we make it even simpler? Yep, that's right where we're going. If, let's say you're going to use the Maps app on your phone. The first thing it does is it says, okay, I'm right here. And you'll say, okay, I want to go over there. I want to go to Johnny's house, or I want to go to the mall, or I want to go shopping. You have your source and you have a destination. You know where you want to go. So for that map app, if that map app just decided to take your source where you are right now, your desire, which is the data, attach them together, and just automatically whisk you away in your new 2040 car, 2030 car, and immediately and automatically take you to your destination, that would be like your map app being a router on the network. Flip that around another way. Let's say, same smartphone, you want to turn the lights on at your house, you want to make sure the doors are locked, or etc., etc. You know where you're at. Your app knows where in your dwelling those devices are. They've already been associated with your network, I would assume. And so you would just say, turn lights on, do door, whatever, and it would adjust. Okay, that's still not simple enough. Okay, you pick up your phone and you call for pizza. Most of the big chains have caller ID, and if you've ever called there before, they already know, based on that caller ID, where you're at. Pizza arrives at your house. You didn't go anywhere, you didn't do anything. You just made a request. They took your request in a form of data, they completed your menu, put it in a box, dropped it in a car, and ran it to your house. Okay, so that's getting better, but we're still not there. Let's take a look at this example for practicalnetworking.net. Shows a data whatever and an IP address that's associated together. But as you notice, as it goes through, it starts with a MAC address. The data goes out, and then the MAC address goes away, and then a new one's added. Then it goes away, new one, away, a new one's added. Finally gets there to where the receiver, the destination, the source, target, the service, strips away the MAC address, grabs the IP address because it needs that. It takes the data into some kind of processing on that end. Once it's done, it'll say, oh, okay, here's my resulting data, here's my IP address, but I need you to throw it toward that IP address. And that's a whole nother section. But the point of the MAC address is it allows a physical route from the the first server to a router to a router to a router to a destination. All of those have different MAC addresses. So basically, the MAC address is a physical characteristic or a physical node or physical location on your network. It is a physical device. It's a physical router, etc., etc. Yes, there can be virtual, and yes, you can clone them. We're not talking about that. We're just trying to talk about MAC addresses. Let's get into a MAC address. Let's talk about some of the good, the bad, and the ugly. But before we get to that, we need to talk about one small little detail. A MAC address is typically a hexadecimal, well, it's always a hexadecimal number. And hex values are 0 through 9, A through F. And you can't look at that 0 through 9 as 0 through 9. It's not the same as our 0 through 9. We use a 10-based system to do numbers. Binary uses a 2. Hexes uses, should say 16. 0 through 9, and then A through F 15. It's 16 designators. Well, kind of skip that. You can find out about hexadecimal, go to Wikipedia or whatever. Typically, these are formed in some form of 2 letters, a colon, 2 letters, a colon, right on through, and you have 6 sets of these. Now, that is the common way we typically see hex addresses done with these, etc., with colons, segmenting them out. The standard way of doing it is those colons are supposed to be hyphens. It should be 2 letters, hyphen, 2 letters, hyphen, 2 letters, etc., straight across. There are 6 sets of these. Now, each set, there are 2 groups, 3 here, 3 here. They designate, the first 3 designates the manufacturer. The second set designates the device, things characteristically with that device that makes it unique. Now, the first 3 sets are actually assigned by the Institute of Electrical and Electronics Engineers, IEEE. I happen to be a section chair of a local chapter of the IEEE. The second set is just unique to the device. What makes the first set beneficial is this is an international standards body that defines, okay, ASUS has this identifier, and MSI has that one, and Linksys has that one, and Cisco has that one. Each one of those manufacturers has their own. So, as promised, we're to the point of this, we're going to talk about the good and the bad of MAC addresses. The good aspect of a MAC address is it allows a device to be identified. The bad aspect of a MAC address is it allows a device to be identified. Basically, it's the same aspect. I would say benefit, but not everybody would see this as a benefit for both situations or all situations. Let's do an example for good. Several years ago, I was running some early version of Linux. I don't remember if it was a Mandrake or if it was an early version of Fedora or SUSE or what it was. I ran them all. I needed to find a firmware. Device drivers in Linux are called firmware. So I needed a driver for Linux to allow my wireless Broadcom, I think it was, networking device to work. And so I couldn't find out who made it, but I had a MAC address. So I was able to take the MAC address and I was able to look it up, find out that it was a Broadcom, and then from there, grab Broadcom packages from the repository for Linux software, grabbed it, installed it, rebooted, and I only rebooted because of other situations, firewalls and etc. I have Wi-Fi. Life's great. It's a great use of the MAC address. Now, let's look at an example for a bad for MAC addresses. I'm going to go, let's switch this over. I use DuckDuckGo. We're going to look up ASUS GT AX11000 router. In a couple of days, there's a specific reason why I'm doing this. You'll find that as that video is released. And so I'm going to go, okay, we have a router. What good's that going to do, you might ask. Well, let's see. Let's go to images. So we see a top of a router top. We see a bunch of tops, scroll down, tops. We'll scroll through here. It won't take long. Somebody's going to do it. Somebody's going to mess up. Now, if you notice this box, it shows the white label. There will be a MAC address on that box, but that's probably going to be a little bit of a pain. I'm not sure we can get that one easy enough. So we'll just keep scrolling, looking. And here's the bottom of a router. So if I click on that, well, that's kind of far off. I'm not sure we're going to be able to find that. So the problem is, as you might well know, is a lot of reviewers do these open box things on their channels. And there's a thing called doxing where you put your real name, credit card, your IP address, your street address. You put something out. That could also happen when you're doing hardware, and a MAC address or an IP address. Those are two very useful tools. Here's one that's got the bottom of the router straight up in the air. So the entire MAC address is right there. We can zoom in, we could find out what that is. So to give you an example of the other type, I'm looking for someone who did it with the box. I remember his face, so it's got to be down here. But yeah, we've gone through a lot of pictures. I was able to find a MAC address doing this off of a review site where someone was showing their new router off. And so what we're going to do is I'm going to go to macaddress.io, and as you see, it says MAC address vendor lookup. Like I said earlier, there's tools like this all over the internet. This is nothing special. This is just the first one I came across. If you notice, they have standardized, no, wait, they do not. They have the common version with the colons. So I'm going to put in the MAC address that I found, which is 049226 capital E 18F50. If I did that right and we hit enter, it shows you. Now we already know that we're looking up an ASUS ROG GTAX 11000. But when you look up the information, it comes up and it says, yes, it's an ASUS, made in Taiwan, gives you the boundaries for its IP addresses, etc., 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 etc. And so we know it's an ASUS. You might be thinking, well, what's the difference of that? Well, if you go to something like Routersploit, you go to a website like Routersploit modules. Let's look at an exploits routers, because we know we're looking at a router. Then you can go under ASUS, and granted, these are years old, but you may take comfort now, oh, those are years old. They've probably been fixed. You're probably correct, but 2 or 3 years ago they weren't fixed. And there could be a new one now that's not fixed. You could go there. You could also do a Metasploit, and you can go under the docs, and then you can look under discovery, which allows you to run scans, look for exploits, payloads, the whole thing. And you there again, because you know it's a router and you also know that it's an ASUS, you can customize and target those devices. Now I understand you have to have the permissions and the access you need to run this off. So yeah, there are things, but the issue is a MAC address is a physical address. And though you may not be able to say, okay, that MAC address is at such and such, but let me throw this scenario at you. Let's throw a theoretical scenario that's never happened and I have no knowledge of at you. Let's say you do an open box on a network, on a video, and let's say, I don't know who saw your MAC address, and then I send you an email about something else. You respond back to me your email, to my email. And in the headers of the email, I have your IP address. I know where you sent that email from. I now have your email address, I have your MAC address, and I'm able to start taking it and deconstructing or working my way in your system, because now I have 2 good solid pieces of information that I can use. So if I have your IP address and I happen to know that that particular model or manufacturer device has certain flaws, that I can go in and execute arbitrary code, which is what one of these ASUS exploits was. You could actually go in and you could change settings and do things. We would never want anybody in our router to change settings without our knowledge, would we? But that's the significance of the MAC address. It associates a physical device with whatever traffic goes through it, which typically involves IP addresses that we can trace back and connect it to. I hope that helps you understand better the significance of MAC addresses, because they definitely do come up a lot. A lot of security stuff is discussed about those. I purposely have not discussed virtual MAC addresses, where you can have virtual machines that have their own MAC addresses and their own fake networks, virtual LANs, and everything else. I also haven't discussed where a device cloned a MAC address to something else. It used to be on DSL modems, you would clone the MAC address in the modem of the computer it was hooked to, it, or the router. You'd have to go into the modem and you would have to put those numbers in, and away you would go. It would basically, that's what it was sending to the world, even though that's not what was actually real in the network. We're not talking about any of that. We're simply talking about the physical data layer that a MAC address operates on, to where it takes data, connects it to an IP address, and then sends it on its journey. That's the point and purpose of a MAC address. If you found this video helpful, click the like. If you haven't yet, go ahead and subscribe. Hit the notification bell icon, and also take advantage of our Patreon and our direct donations page if you'd like to support our channel. My name is Sean Wilkerson. This has been Hacker Eyes, and we'll catch you in the next one.